All right, so we're going to look at fractions. All I'm going to do is just simply show you how to solve questions involving fractions. We're going to just work with examples, and then we're going to do a couple challenging questions, and that'll be it. So, example 1, let's look at addition, and we're going to add 7 over 15 plus 2 over 15. The first thing you need to do is to find your LCM. In this case, the two of them, the LCM is 15. And then you take this 15 divided by this 15 and you get 1. And then you multiply it by the numerator of the first fraction. Then you bring down the operator that's in the center. And then you do the same thing on the other side. So you take the LCM divided by this denominator, you get 1, and then you multiply by the numerator, which is 2. So you have 7 plus 2 over 15, which is equal to 9 over 15. And then we reduce the fraction. So 3 into 9 is 3, and 3 into 15 is 5. So the fraction is 3 over 5. This is what you will call a proper fraction. All right. Let's look at another example, just like this one. Let's look at example 2. The next example is 4 on 11 plus 7 on 22. The LCM on this one will be 22. So we take 22, the LCM 22, and you divide it by the denominator of the first fraction, we get 2. Open bracket, we multiply by the numerator, which is 4. We bring down the operator, which is plus. We take 22 LCM and divide by 22 the denominator, we get 1, and then we multiply by 7. Then we expand and simplify. So 4 2s are 8, put back a plus, 1 by 7 is 7, divide by 22. And we will be able to get 15 upon 22. All right, nothing difficult so far. The next one we are going to look at is example number 3. This is going to be one involving subtraction. So we have 9 over 17 minus 3 over 17, and you would perform the operations the same way that you did the additions. So we first put down the LCM, which is 17, and then we take 17, the LCM 17, and divide it by the denominator 17, we get 1, so we have 1 into 9, minus, we have 17 divided by 17, then multiply by 3, and we expand, so that is 9 minus 3 over 17. That will leave us with 6 over 17. Notice again, all we did was different, is just bring down a different operator. So the operator here was negative instead of positive. Let's look at example number 4. With example number 4, we have 13 over 15 minus 2 over 5. And we're solving that one now. So we find the LCM. The LCM of 15 and 5 is 15. We take the LCM 15 divided by the denominator 15, and we get 1, multiplied by the numerator 13. Then we bring down the negative sign. Then we do the same thing with the second fraction. So we take the LCM 15 divided by the denominator 5, we get 3. Multiply it by the numerator of the second fraction, which is 2, and we would be able to get that. We expand, we get 13 minus 6 over 15. 13 minus 6 is 10 minus 3, which is 7 over 15. Now, the addition and subtraction can be done without considering what the LCM is. Say, for example, you have two numbers where it's very difficult to figure out the LCM. The best and easiest way to deal with it is to multiply the denominators. So let's say this is a method number 2 that deals with both addition and subtraction that you can use for both addition and subtraction. So we have 13 over 15 minus 2 over 5. And what we do is we multiply the denominators. So we have 15 multiplied by 5. That is 75. And then we just simply take these and multiply them together. So 13 by 5 is 65. Put down the minus sign operator. And then 15 by 2 is 30. And then we simplify that and solve it. So we have here 35 over 75. When we divide 35 by 5, we get 7. And 75 divided by 5, we get 15. And the answer is the same, 7 over 15. You can use that for any one of those fractions if you can't figure out the LCM. The next thing that we're going to do is we're going to look at example number 5. Let me just change this. I'm writing bad. Example number 5. And we have 4 over 9 multiplied by 5 over 8. And what we're doing here is you're going to just take the top and multiply it by the top, and take the bottom and multiply it by the bottom whenever you're doing a fraction like this. So for this one, we will have a value of 5 fours are 20, and 9 by 8 is 72. And then you reduce the fraction. So what I like to do to reduce a fraction is just literally a prime number division. So I keep dividing by prime numbers until I can't find a prime number that I can divide both of them by. So the first prime number I'll divide by is 2. So 20 divided by 2 is 10. And 72 divided by 2 is 36. So I get 10 over 36. I do the same thing again. So next prime number is 2. So I look at that and I'll get 5. 2 into this 5. And then 2 into this 18. So I get 5 over 18. Number 6, just to make sure you understand that what you're doing, example, as I said, it's just top multiplied by top and bottom by bottom. So we just look at two different fractions now. So the top multiplied by the top is 21 by 5. So 21 by 5 is 105. And then 25 by 18 is 250. And we get that over 450. And again, we do a prime number division. So I can do 5 here and get 21, and 5 here and get 90. So 21, 90. Then I can do 3. So 3 into this, 7. 3 into this, 30. And that's literally how it can be done. You don't need to divide by 3 first. Sorry, you don't need to divide by 5 first. You can divide by 3 first. And you'll still end up with the same answer. Now we're going on to example 7. So in example number 7, we are looking at divisions. So we have 9 over 28, 28 divided by 3 over 14. And to do this, it's the same kind of operations as before. So what you would do is you would first rewrite the entire fraction. So we'll rewrite it 9 divided by 28. And then we change this division to a multiplication sign. And then we invert the last fraction. So we end up with something like that. We can multiply it first, or we can reduce it first before we multiply. I prefer to reduce and then multiply because the numbers are easier to multiply. So 3 divided by 3 is 1. 3 divided by 9 is 3. 14 divided by 14 is 1. 14 divided by 28 is 2, and we have here 3 over 2. This here is what you would call an improper fraction. Most of the time, you're not supposed to leave your answer as an improper fraction. So what you do is you write it in a different form. This here is equivalent to 1 and 1 over 2. You simply get this by seeing how many times 3 can be divided by 2, and you simply take the remainder and put it over the 2. So 3 can be divided by 2 once, and then it will remain with 1. So you put the remainder 1 over 2. This number here is what you would call a mixed number fraction. Now you prefer your answers to be in a mixed number fraction form rather than improper fraction form. So it's either you leave it in mixed number fraction form or you put it in the form of a proper fraction. I will do one more example with divisions. So example number 8. And then we have something like this, 39 divided by 50 divided by 13 over 20. Again, what we do is we rewrite the entire process. So we rewrite the entire equation formula. It's 39 divided by 50, change the division to multiplication, and then we invert the last one, which is 20 over 13. 20 divided by 10 is 2, 50 divided by 10 is 5, 13 divided by 13 is 1, 13 divided by 39 divided by 13 is 3. So 3 2s are 6, and divided by 5 by 1, 5. Again, this is an improper fraction, so we want to write it in a mixed number fraction, and 6 divided by 5 leaves 1, and we have a remainder of 1, so we put that 1 over the 5. Now, right now you'd think that, okay, I'm not giving you anything challenging, so the next 4 examples are going to be challenging fractions to solve, so that you can see exactly how these questions are dealt with. So I am going to look at the next example, and this is example 9. So we have 2 1/4 multiplied by 4 on 5 all over 3 on 5 minus a half. Now, previously I showed you that we have mixed number fraction and improper fraction. The best way to solve questions involving mixed number fractions is to convert them to improper fractions. So the mixed number fraction is 2 1/4, and to convert it to an improper fraction, we simply reverse what we did before. We would multiply by the denominator, multiply the whole number by the denominator, and then add the remainder. So 4 2s are 8 plus 1 is 9, and then we'll put it over the denominator, which is 4. And then we rewrite the question. Now, you don't need to do this on the side here. I just did it so you can see how you could convert between the two of them. Right? So we have 9 over 4 multiplied by 4 over 5 all over 3 over 5 minus 1 over 2. We simplify the top, so we see 4 cancels with 4, leaves 1, and then we have on the top 9 over 5. Then on the underneath we have a subtraction to do, so we have to find first the denominator. We have to find first the LCM. The LCM of 5 and 2 is 10. So we solve that. 6 minus 5, it's 9 over 5 all over 1 over 10. And this here is the same as saying 9 on 5 divided by 1 on 10, and we just simply follow division procedures for that. So we end up with 9 on 5 multiplied by 10 on 1. 5 into 5, 1, 5 into 10, 2, and we get an answer of 18. I'm going to do 3 more questions, and what you can do is once I put the question up, you can pause the video, try and solve the question, and come back for the answer at the end. So example 10. 1 and 1 over 7 minus 3 over 4 all over 2.5 multiplied by 1 on 5. Again, we want to change all the mixed number fractions to improper fractions first. So 1 on 7 changed is going to be 7 by 1 is 7, plus 1 is 8, so 8 on 7. And then we have 2.5. 2 by 2 is 4, plus 1 is 5, so 5 over 2. Rewriting, we have 8 over 7 minus 3 over 4 all over 5 over 2 multiplied by 1 over 5. Solving the top, we see that our LCM is 28. And then we have, on the numerator, we have 32 minus 21. And then we have this 5 cancelled with this 5, leaving 1 and remain with a half on the underneath. Solving the top, we have 32 minus 21, which is just simply 11 over 28, divided by 1 over 2. It's equivalent to writing 11 over 28 multiplied by 2 over 1. 2 into 2, 1. 2 into this, 14. And we will have 11 over 14. Next, we're going on to example number 11. And the question is 3 and 3 over 4 all over 2 and 1 over 3 minus 5 on 6. And then to solve this question, again, we convert the mixed number fractions to improper fractions. So 4 3s are 12, plus 3 is 15. 2 and 1/3. 3 2s are 6, plus 1 is 7. And we will end up with 15 over 4 all over 7 over 3 minus 5 over 6. We do this subtraction and we will get 15 over 4 all over 6 3s are 18. Then we take, the LCM is 6. And we then, from the 6, we see that 6 divided by 3 is 2, so it's 2 by 7 minus 6 divided by 6 is 1, 1 by 5 is 5. So 15 over 4 all over 14 minus 5 over 6, which is 15 over 4 divided by 9 over 6. This is equivalent to 15 over 14 multiplied by 6 over 9. 2 into 6 is 3. 2 into 14 is 7. 3 into 3 is 1. 3 into 9 is 3. 3 into 3 is 1. 3 into 15 is 5. And we have 5 over 7. Then we have example number 12. And this is the last one. Example number 12, 2 1/4 plus 1 and 1 over 8 all over 4 and 1 over 2. So converting each of these to improper fractions, we have 2 1/4 is equal to 4 2s are 8, plus 1 is 9 on 4. And we have 1 and 1 over 8. 1 by 8 is 8, plus 1 is 9 over 4. 9 over 8, sorry. Then we have 4 and 1 over 2. 4 2s are 8, plus 1 is 9, 9 over 2. Rewriting everything, we have 9 over 4 plus 9 over 8 all over 9 over 2. Solving it up, we have the LCM of 4 and 8 is 8. 8 divided by 4 is 2, so we have 2 into 9. 8 divided by 8 is 1 to 9 all over 9 over 2. And then it will be equal to 18 plus 9 over 8 all over 9 over 2. 18 and 9 is 27, so we have 27 over 8 divided by 9 over 2. And this will be equal to 27 over 8 multiplied by 2 over 9. 2 into 2, 1, 2 into this, 4, 3 into this, 3, 3 into this, 9, 3 into 3, 1, 3 into this, 3. Now I did it this way so that you can see you can just start from the lowest prime number you could think of and you can keep going until you get the answer finished. Otherwise I would have just done 9 divided by 9 is 1 and 27 divided by 9 is 3. So get 3 over 4 as your answer. If you see any errors that you want to mention to me, just let me know and I will fix it in an updated version of the video. Thank you.